In this lesson, I'm going to do few questions on solving quadratic equations and quadratic inequalities, and also finding the intersection of quadratic function and linear function. So the first question we have is x squared is equal to 225, and you have to solve this quadratic equation. This is the simplest one when you have only x squared term. The standard form of the quadratic function is ax squared plus bx plus c. So here you have only x squared term. So 225 is a perfect square of 15. So 15 square is 225. And since it's quadratic means degree 2. So there will be two solutions for this equation. X is equal to plus minus 15. Then the second one is when you have 3x squared minus 72 is 0. So this one is when your x term is missing. So you have ax squared plus minus c equal to 0. So when you have this kind of equation or any kind of quadratic equation, the first thing you should do is look for common. If there is anything common, you take that common out. In this case, 3 is common. So you will get 3, and then x squared minus 24 is 0. The product of two numbers is 0 when one of them has to be 0. And this 3 is not equal to 0, which means x squared minus 24 has to be 0. And then again, this question becomes same question as question number 1. So you will have x squared is equal to, this is same as x squared is equal to 24, but 24 is not a perfect square number. So x is equal to plus minus square root of 24. And now we need to simplify this radical. And we know 24 is 4 times 6. And square root of 4, you can always separate the square root. So square root of 4 is 2. So x is equal to plus minus 2 square root of 6. Again, for quadratic, you have two solutions. One is with plus and another one is with negative. The next one is when you have f of x, which is x squared minus 2x plus 2, and g of x is negative 2x plus 3. And you need to find the value of x when f of x is equal to gx. So I did this question in two different ways. One is algebraically, and then second one is using GDC. So for algebraical way, since this f of x and g of x, they are equal, and when they are equal, then we have to find the value of x. And you have to find the point of intersections for this one. So not only x, we'll also find the y value for where these two graphs intersect or these two functions intersect. So for algebraical, we will equate them, and then you can see negative 2x and negative 2x, they will cancel out. So you get x squared. Here you will have x squared plus 2, which is equal to 3. So x squared is equal to 1, and you get x is equal to plus minus 1. Now you can substitute this plus minus 1 either in f of x or g of x, and this will give you the y coordinate for x is equal to 1 and x is equal to negative 1. So when I substituted x is equal to 1 in f of x, I got f of x is 1. And when I substituted x is negative 1 in f of x, the value which we got is 5. So the points where these two graphs are going to intersect is 1, 1 and negative 1, 5. But it is much easier to substitute in gx because here you have a linear function. So if you see one of the function is linear, then you should substitute x, the value of x in the linear one. Now, how to use GDC to find the point of intersection in this case? So first thing is we will graph, enter the equation. So the y1 is equal to x squared minus 2x plus 2, and then we have g of x, which is equal to negative 2x plus 3. So there's multiple ways to use GDC in this case. So what you can do is you go to second, so press on y and then graph. So we can see the point of intersection from the graph. So to find the point of intersection from the graph, we need to click on second and then trace and then go to intersect, and then you can move the points closer to the intersection 1, and then you enter it 3 times and you will get the intersection point. Similarly, you can find the another intersection point. So you need to quit, then go to graph again, and go to second, trace, intersect, and from here, enter 3 times, because since we are dealing with 2 curves, and then you get intersection -1, 5. So this is one way of finding the intersections in this case. The another one is if you do not want to use the graph, after you enter your y1, which is x squared minus 2x plus 2, and y2 is -2x plus 3, what else you can do is you can go to second table set, and we can set this table maybe at 0, or maybe some negative numbers, because answer can be negative. So let's say -1, -1, and then we can also go to second. From here, if we press on second table, then you can see from here, I can see when x is equal to -1, you get y1 is 5 and y2 is 5. So -1, 5 will be a solution. And then you have when x is 1, your y1 is 1 and 1. But this method is not going to work if the answer is not a whole number, because then we don't know. And if we don't know, if the answer is not whole number, then we don't know what will be, because in this case what I did is table start is -9 and delta table is 1. But if it's decimal, we will miss the decimal solution simply because our delta table is 1 in this case. So if the value of this intersection will be somewhere between -2 and -1, then we'll miss out that information. So this method is not going to work if the solution is not a whole number. Then the next one is using a GDC, you have to solve this inequality, which is x squared minus 3x is less than equal to 10. And I also did it algebraically. So you can see from here, x squared minus 3x is less than equal to 10. So you move everything on one side, and then we can factorize this. So when you factorize a quadratic function, you need to think of a factor of a constant term. Now, there could be multiple factors here. So factors of 10 is 1, 10, and then you have 2 and 5. So we need to see which one works. So when you multiply the factors, it should give you constant term, and when you add the factors, it should give you the middle term. And when you add them, this is the case when you have coefficient of x squared is equal to 1. So in this case, 2 and 5 is going to work, but since we have negative here, which means one number has to be negative. Now, which number is negative? It depends on the coefficient of x. In this case, the coefficient of x is negative, which means we should put negative with the larger number. So these are the factors, x plus 2 and x minus 5 less than equal to 0. This video is not focused on how to factorize. So this is more, I will do a couple of examples on factorization, but this is more like solving quadratic equation by factorization. So you get x plus 2x minus 5 less than equal to 0. Now, if you want to do this, you can graph this because we already have x plus 2 and x minus 5. So we know these are the intercepts. And this means y less than equal to 0 means the solution will be below x-axis. So the solution is from -2 to 5, and -2 and 5 is included because here we have equal to. So that would be the solution in this case. And if you do it graphically using GDC, the steps will be same, but you don't have to do any of this because this is more like algebraically, and then I use this to graph it. But if you're just using a graph, then what you need to do here is you just simply substitute your function, which is here x squared. So x squared and then -3x, -10, and then you graph it. So from graph, you can see what will be the solution here. So the portion which is below, because it simply means y is less than equal to 0, and y less than equal to 0 is from -2 to 5 here. The next is solve these two equations. 3x plus 4y is equal to 5 and 2x plus 3y is equal to -1. So I'm going to show you how to do it algebraically, and then how can we use GDC in this case. So algebraically also, whenever you have simultaneous equations, either we prefer to use elimination or substitution method. But substitution method is more useful when you have the coefficient of one of the variable as 1. Then you can easily isolate that variable. But in this equation, we do not have any variable where the coefficient is 1. So I'm going to use elimination method here. Now to use the elimination method, we need to make one of the variable equal and opposite. So it doesn't matter, it can be x or it can be y. I decided to make the coefficient of x to be same, equal and opposite. So here we had 3, here we have 2. So first one I multiplied this by 2, and the second one I multiply by -3 because I wanted the coefficient to be equal and opposite since both of them are positive. So we multiply this by -3 so that this becomes -6. So when we multiply the first one by 2, we got 6x plus 8y is equal to 10. Multiplying second by -3 gave me -6x, -9y is equal to 3. And when we add them, we got -y is 13 and y is -13. Now you can substitute this any of the equation, doesn't matter. So I substituted in the first one. You can also substitute in the second one. The answer should be same. So when I substituted y is -13, so you got 3x plus 4 times -13 is 5. And then 3x minus 52 is 5. And 3x is equal to 57. So you got x is 57 over 3, which is 19. So this is the solution here. Now, if we want to use calculator for this question, then you need to have, if you are using TI-84 calculator, then you need an application. The application is PLYSMLT2. This is number 9. So here we are solving simultaneous equation solver, and we are dealing with 2 equations and 2 unknowns. So we don't have to change anything here. That is the default setting. And we change the number of equations. If we have more than 2 equations, we select accordingly. But in this question, we have 2 equations and 2 unknowns, which is x and y. So we don't have to change anything here. So we go to next. And now we'll enter the coefficients here. So in the first one, the coefficients are 3, 4, and 5 is the constant term. Okay, so this is 3, 4, and then enter. And then constant term is 5, enter. So first thing you need to complete is the first equation. Then 2, 3, and -1. Okay, it's 2. So this is 3. And then you have -1. And then you press on solve by pressing on graph, and then you will get the solution. In this case also you can see x is 19 and y is -13. So this is how you can use calculator to solve simultaneous equations. So the next question is solving the quadratic equation by factorization. So to do that, you have, so I'm doing the same ones with the coefficient of x square as 1, and the another one is the coefficient of x square is not equal to 1. So I did this in 2 different ways. The first one is using the factorization, where you find the factors of a constant term. Now again, there are various factors of 40, but then you need to see that which one, when you add or subtract, give you the middle term. So here in this case, 40 is 5 times 8. But then again, we need this as negative, which means one number has to be negative. But whether that number is the smallest or the largest will depend on what you have as a middle term, the sign for the middle term. Here it is +3, which means we have to have negative with the smallest number. So these are the factors: x minus 5, x plus 8 equal to 0. To solve the equation, either this is 0 or that is x plus 8 is 0. So you got x is 5 and x is -8. The other way of doing this is by the method of grouping. So what you can do is you can split the middle term. So you need to think about how do you split it so that when you group them, then you should get the same factor inside the bracket. So again, here because I know that for 40, we have 8 times 5, 40, and then 8 minus 5 give me 3. So that's why we are rewriting this 3x as 8x minus 5x. And from first and second, x is common. So you got x plus 8. Now I want this bracket exactly the same as x plus 8. So which means here I have to take negative 5 common. So x plus 8 is 0. Now from this one, again, x plus 8 is common. So then you have x minus 5 in the bracket, which is equal to 0. And you get x is 5 and x is negative 8. Similarly here, when you have 2x squared minus 7x minus 4 is 0. So now here, in the previous one, you had x square, which was easy, and you got x and x. This one is not that hard because 2x squared and 2 is a prime number. So you don't have a lot of possibilities for this. The only factors for 2x squared is going to be 2x and x. And then for 4, it's 1 and 4, or it can be 2 and 2. But you can see 2 and 2 is not going to work because 2 times 2 is 4 and 2 times x is 2. When I add, or if I subtract, it's not going to give me 7. So this is not going to work. So 1 and 4 will work. And now we need negative 7. So when I multiply this, it gives me 8x and this gives me x, but I need negative 7x. So which means this has to be negative. That's why this is negative 4. So when we write them, we always write them 2x plus 1 and then x minus 4 equal to 0. And I got x is negative half and x is equal to 4. Now the same can be done using the method of grouping. So you have 2x squared. I have to rewrite negative 7x. So that will be negative 8x plus x minus 4 because I need this bracket to be same as x minus 4. This can be quite hard to come up with how do I split the middle term because here you had 2 times 4 which is 8. So then you have to try maybe negative 8x plus x. So now from this one you group them. 2x is common so you get x minus 4. Here 1 is common so x minus 4. And then again from this one you have x minus 4 common. So you take x minus 4. So from here 2x is left, from here it is 1. And it gives you the same answer. X is equal to negative half and x is equal to 4. That's it for this lesson. Thank you. And if you like my lesson, please subscribe to my channel. Thank you.